So guys, welcome, and thank you for coming. And if I don't give you the right to talk, you can still chat. You can surely say something. Just to verify that, here I am, is our chat. So I'm saying hello. Okay, you should be able to see that hello. You should also be able to answer something. Cool, so I think we are ready to start. And I allowed everybody to talk, people who I know and who I don't know, and we're ready to start. So we already know what it is about. It's about Scala, and it's a result of my recent discoveries. So not only about Scala in general, but I'll give you an actual story. So here we are. I have prepared a couple slide decks for that. Well, really a couple documents. So this is the slide deck. That's what we're going to go through. Okay, and that's okay. That slide deck is based on the course, but we're not going to do any kind of course. So what I want to do is I want to say, here's a slideshow. And let's start it from the very beginning. But before we do the slideshow, I want to show you a document which you will probably also get at the end of our webinar, right here. Okay, and that's because I'm really basing it all more on a story. So I kind of go through that paper with you. I prepared it for Forbes Council's publication, and that's where right now it is being edited, and it will be published probably in a week at most. And the story, at least my personal story with Scala, was that long time ago, 2008, when I first saw the Scala. So then the project was, when project in Scala was really problematic. I don't know if you remember that far back in computing science, that's like a millennium, 10 years back, right? But essentially couldn't find people who would do this Scala programming. We'll talk about why. So whether that project was successful and or no, it doesn't matter. What was important is that people who were project leads, they were nervous about, they would ask you, can you join a project with Scala? We know you know Java, okay, but that's not the point. So let's dig into that, exactly that. What happened at first is that Twitter was the first one to make a big splash. If you go and check, if you're interested in such things as adoption, then they will usually quote that it is an open question. Does Twitter really still use it? No, we'll talk about why is that. But then there was a definite push. So Scala is the language that allows you to talk in the terms of, let's say, bestsellers, to be like gods and create other worlds. So Scala allows you to create more languages. We'll do that also today. And one of the languages that Scala created was Spark. Now, what is Spark? Let me draw a picture. I think it will be a good idea if we do this. If we do a little picture here. And let's do another picture. I was talking about something, but that's my whiteboard. So that makes it much more real when you do the whiteboarding. So here's my Scala, and I'm saying that the Scala is claiming superpowers. So let's say superpowers. And that's exactly why you are here, guys, because that's what the title of the webinar was. So, okay, Scala has superpowers. And then there comes big data. Okay. So what can Scala do for big data? Big data, all right? Let's do it like big data, okay? So what Scala can do for big data is it allows you to create more languages. So you can say, I'll create Scala for big data. like this. That will be part of my superpowers. Apologize for typing this way. For big data. In other words, I want to create what's called domain-specific language, an extension of my regular Scala language that will give me the superpowers. So they did it, and that is exactly what is called Spark. You can think of Spark as a replacement for Hadoop, but what's important is that it is a domain-specific language for big data, DSL for big data. Okay, so that is what is special about Scala. But for that, you need to know Scala and you need to understand how to use it right. You see, Scala, you can use it as a Java programmer. That makes no big point. In Scala, you don't have to do the semicolon. So if you just want to use Scala because you don't have to use the semicolon, I don't think that's a good enough reason. Okay, Twitter did it right. They made a point of saving the fail whale. Long time ago, there was such a thing that when Twitter was overpowered, not available, they would show you the fail whale. And when they rewrote the engine in Scala, the fail whale went away. Good, we will be able to verify why that happened. Meanwhile, there is a talk that no, they don't really use Scala at Twitter either anymore or not that much. And of course, I'll tell you right away, not everybody can get that superpower. So if a regular program, you take a regular program, and sorry about guys who use Python, but let's say who learned programming in Python, unless he is a genius programmer, he won't get it. So that's a special superpower you will get if you are interested in programming. Now, what happened then in history is that Spark as one beautiful application of Scala as a superpower, as a domain-specific language for big data, got very prominent. You know, that was a great advantage. The fact that it was in Scala did not matter at all, but people thought that it does. So Scala got very popular. It went on to 20th language on the TOB index. So in my personal story, I really taught Scala recently because some renewed interest. There was a major bank who wanted to think of maybe we can do something better than what we're used to, and true, yes, they can. So that provoked my own interest. I reviewed our course. I also took the Lightband course. I believe their course is really great. And you can take that too. It's open, it's free. Now they tell me that Scala is number 14 on the Redmond index, and they say Redmond is better than TOB. But they might have a reason for that, because on TOB it's now 46. So why? What's going on? So people initially thought that Scala is great if you know how to skip that semicolon. So they took that and it led them nowhere. You need to understand exactly what is that's special. So that's my story that happened. And they gave me, those guys at Lightband gave me additional interesting things. One of them, they said they're pretty high, but that was not the point. The point that I wanted to make is this. It doesn't really depend upon the language adoption. That's not the point. What is important is that as an analogy, you are going to a new party. So every day there are great news about COVID and not bad news about COVID. Unfortunately, you know that. And let's say there are good news today. New York is all open, you're planning a party. So you want to make a bash, you want to look great, you're buying, let's say, a t-shirt or something else. So how do you do this? Well, if you really want something extremely great, I don't think you go by the popularity. Walmart is a very popular store. I don't think you go there to create the special looks. You go to, well, let's say my favorite brand, my wife's favorite brand, Donna Karan. So you go there, you buy something nice. The only problem is that it costs. So that's the exact analogy. You want a popular language, you go with Python. It's today #1 on every index. But if you want something awesome power, not just, and by the way, Python will give you all that maybe Scala will give you, but you have to be extremely smart understanding that. And once you are, go with Scala. So, okay, you go there, you go to a very special boutique place, you get the right thing, you impress everybody, nobody can be like you. But that's a lot of learning, right? That's very expensive in terms of money, if we are using an analogy of buying clothing, and that's very expensive in terms of time, if we're using the analogy of learning. So here's my suggestion. If you really want to buy some great clothing, you go to eBay and you become smart about, you can look at what are the best advice for doing it on eBay, and you'll pay much less. You'll pay 5 times less than the list price, 5-10 times less than the list price. There is a way, there is kind of an eBay for Scala. The eBay for Scala is called Scala Cookbook. I believe that's so important that let's spend a little time on that. So Scala Cookbook, first of all, it exists here on the web. You just go and you do Scala Cookbook. And if you don't know that, I'm giving you something great. By the way, you see, it's not all that maintained, but let's go. I hope they will let us in. Right, so lots of advice on how to do it right. Now, keep in mind that this is not maintained. So it doesn't have the latest and greatest version and latest and greatest thinking either. That's what I'm warning you about. You need to go to Amazon. And here you find the 2nd edition, Scala Cookbook, 2nd edition. Now, I'm comparing. I'm going through because I'm using this 2nd edition, this one, and this is much better, much more than the first one. So the first one is okay. There's nothing very wrong with that. But if you want to be really using it, and we agree, I believe, that we are doing something good, we're doing something very powerful. So for that, you would need to use the 2nd edition. Okay, so now that we agree that that's not how we choose the language, not by popularity, but what it can do, here in this article, I'll show you exactly what it can do. Well, for that, I don't need the article. I'll go back, I'll close that. You will get, I believe, all the attachments after the webinar, so you'll get them in a day or two, so no worries about this. And let's go back to our slides. Here we are, right? So now that, and I just took some of the slides because they're good enough. And first of all, what is Scala? For those people who are not familiar, the first fact is that it's a scalable language, and that's why it is called Scala, meaning that first, if you're a Java programmer, you can just start. You will probably understand. Now in Java, you have to say integer a equals 1, and in Scala, you have to say a equals 1. Well, more precisely, you have to say val a equals 1, but they look similar enough. So that will be level 1. And then there are 7 levels. Level number 7 is where you're creating new languages based on that. So here is why it is a scalable language. That scalability is not free. Again, you'll have to learn. Now, I'll show you where it's easy to start, but then it grows and you need to do more work and more knowledge. By the way, it's pronounced Scala, not Scala, because that is an Italian word and it comes to us from the La Scala theater. Now, of course, if you know Italian, then Scala is the staircase. The La Scala simply means a staircase, and that's what it looks like. Has absolutely nothing to do with what we're talking about. It's just a beautiful theater. Oh, by the way, they have all of those La Scala performances, which are great. You have them today you have them on YouTube, just because COVID led to an enormous amount of everything, including paintings and art on the web, back. We have to really go back and control ourselves and not to go to the side, but that's why it's called Scala. So it's based on JVM. So whatever advantages you already have on JVM, that goes here. Now, I'm not checking the texts. Maybe what we will do, nobody I think says anything. Maybe what we will do later is if you want to ask questions, we will. So fact number one, it is based on Java virtual machine, and that's a very alive and well and doing well area of life. So the idea of JVM was in the first place, you write once and then you run everywhere, still applies. There are so many different open source versions of Java and JVM that you can surely do very well there. The next one, it is object-oriented. You can encapsulate your variables, but you should do much better, okay? So this is where the advantages of Scala begin. I'll give you the example right away. I hope you're all programmers, so it makes sense. In Java, there is such a thing as Java beans, right? You put in data and encapsulate the getters and setters. Well, you could do this, but you absolutely should not, because the whole idea of Java beans from the point of view of Scala, in fact, is the wrong idea. Because the getters are okay. Let's say I have an object, let's say I have a car and the car has an engine, and I can get that engine just to inspect it as a read-only object. That's fine. But if I replace that engine, then I'm opening myself to conflicts. Two people replacing the engine at the same time, you can imagine what that means. So in fact, the setter is not a good idea in programming in general, because it leads to all kinds of conflicts and thread conflicts. And Java was designed before there were really threads. We'll talk about this. So Scala does it better. At least I'm promoting this new understanding that I got in the last maybe half a year. Next one, it's functional programming. I'll show you much more precisely what it means, but I'll tell you that there are a couple ways to write the factorial program. One way is just to program everything. Factorial means 1 times 2 times 3 times 4 times 5 and so on until the n. So one way is just to assign all the variables and calculate it. You can imagine what code would look like in Java. But I know that the mathematical definition of factorial is something else. The mathematical definition of factorial is, you know, intuitively it's 1 times 2 times 2 times 3 and so on. But that's not code, right? You cannot do anything with this. So instead, you write this, say that a factorial, let's call it f, right? Full, favorite thing. Okay, so full of n equals n times full of n minus 1. Okay, that is a mathematical definition. If you write it this way, if you write it mathematically, you can ask a friendly mathematician to verify that what you wrote is correct. The problem is that this is not code either, right? Well, with Scala, it is code. You can write such things as recursive functions. I'm not writing it right now, not to distract ourselves, but you can write such things. In other words, what you do is you simply take a function and you write it in terms of Scala definition and let the compiler do it for you. So that's what it means, functional language. You're getting as close to real functional definitions as you can, rather than, in fact, translating all of that in the Java style or what is called imperative programming. Imperative programming is doing a loop. We'll probably have a slide on that. But Functional programming is just writing out the functions and let the compiler take care of that. Okay, that's the statical, functional programming. There are a few other things. Let's go and look at them. So I'm going from now on, I'm going a little bit deeper, taking that little dive to support whatever I said. Now, if you will be bored here and you will leave here, I'll tell you that after this dive, I will talk about two more things. One will be the Akka, the real-time system coding. How do you do threading, but in a much better way, and even forgetting the word threads altogether, just a bunch of piranha fishes that attack your problem. That will come later. So what I'm planning to do is use about 20 minutes total. I don't want to go for an hour. So 45 minutes total. We have about 20 minutes to go. That's the expectations. And now I'll go and do a bit more in detail and then go back and talk about best practices and the real-time framework Akka. So first of all, let's say you want to create a map. That is how you would create a map in Scala. You would say map, and then you will give value from to. So that's very readable. Okay, one advantage, easy to read. And by the way, anybody who knows Java already can pretty much read Scala unless we go a little bit higher for what's called higher order functions, some more functionality that's more in your brain than in the code. But for now, I'm creating a very simple hash map of capitals, country, place. If I add to something, I can do this. That's a nice thing. Usually that only works plus equals, that only works for numbers. But Scala allows you to add those kinds of things to objects. So if I define this new operator for the new operator map, by the way, that won't be a regular Java map, it will be a Scala map, and I'm adding things to that, then plus equal will begin to make sense. So you see a few things here. You see that things are objects, and then you have a lot of control over objects, and you can redefine. You can redefine their operators. Now, another thing that you see here right away is let's drop the boilerplate code. In one example, if you compare boilerplate Hadoop word count and straight Spark word count, and to be precise, so what is word count? We go through all of the files in the universe and we count the number of words. Each specific word gets its count. So that's called the classical hello world example, but in the world of Hadoop, it's called the word count. So that's about 150 lines in Java. Because of all of the boilerplate, now in Spark, which is based on Scala, and the way you talk to it is also influenced by Scala, that's about 5 lines. So you get about 30 lines, 30 times less code. That, of course, is an extreme example, but it's illustrative. Now, when I was trying to write this paper, the editors, they asked me, how can I support this? Well, with the examples that I gave you, you Google for Hadoop map reduce implementation, you'll get those 150 lines. But I was saying that all of the code in Hadoop is 120,000 lines. Whereas all of what you have in Spark is only 50,000 lines, and that's doing 4 times more. So again, my estimate was that you're getting 10 times improvement in productivity. That's not supported. The editors asked me to find a study where I could support. Well, it's very hard to count the number of lines. So my personal belief is that you can get up to 10 times less code because of what you're doing, because of this. So instead of spelling out every instruction, you're writing down the functions. That's one reason why you do it. And in general, because Scala gives you a way to create new languages. That's what I was saying here, that you have new things that you say about Scala right away. It's this. And another thing, well, let's avoid boilerplate altogether. In this particular instance, when Java says system out println, well, system and out is not necessary. You can import the system.out as a package and you get println. Whenever Scala can, it does it. I think that's just syntactic sugar. I think it's just to be nice, because the real advantage is when you learn how to understand and write the code the right way. Practically how we do it? Well, the great source for now is Scala Cookbook. Okay, now the next step is that you can write your own types. You're growing your own language. Here's an example of what you're doing. Again, that same factorial. That's how you will spell it out. Let's read it. I'm defining a function called factorial. I'm giving it a type, big integer, which we'll talk about a little later. And I'm saying if your x is 0, then the answer is 1, or else you just do a recursive call here. And there's a little magic for those people who are into such details. In my case, that factorial call is the last call ever in all of the function body, right? That little thing, I don't say factorial x minus 1 times x. No, I say x times factorial x minus 1 is the key. Why? Because if I say factorial x minus 1 times x, internal Scala compiler has no way to optimize it, and the amount of memory that a recursive call can be potentially enormous. It is proportionate to the number x. So put in 1,000,000 here and you have an overflow in your stack. But for that kind of thing, they have a clever trick that doesn't grow your stack beyond a certain amount. So if you do this, if the last thing that you do is a recursive call itself, they have a special optimizations that will keep your stack under control, which means that practically you can use it. That's what it means. You can use as much of recursive calls as you want, if you take care, and that's the last one. Now, you can make a mistake, right? You can say, I think I did it right, but I don't know what the compiler says. There is an annotation. The annotation says, I forget the name of the annotation, but it says, verify that indeed my code, after all is said and is done, is doing this as the last call. I can tell you later. So what we're doing here is showing you how you can grow the new types. Note this big integer. That's a new type. So with Java, you would have to do things like this. You'd have to define this big integer because there is no way to give a star to the new types. You would say in Java, you have to say x dot multiply, subtract. All of those are not operations. Here, I'm giving it stars. In other words, if you remember C++, it allows you overwriting of operators, operator overwriting. And that's exactly what Scala is doing. So Scala is taking the best lessons that were in fact abandoned. C had it, but it was too hard and it wasn't controlled enough. So I'm kind of bringing it back. Well, I hope that begins, that at this point is when you would say, oh, so I begin to see some kind of light would come up. But here's Akka. So for Akka, I'll show you another picture and we'll be pretty much done. So here's Akka, and I really need another picture here. Here, okay. So here it is. Let's open a place. So first of all, why Akka? Why? Well, because if you are a Java programmer, let's say you're a Java programmer, and we're talking about multi-threaded, many different things at once applications. So in Java, you would have to use the thread pool, give work to threads, and watch that. What happens when the thread dies? What happens when there is more work to do? So you would have to be very close to the hardware, because threading is essentially asking another CPU to do your work. So you would have to be on that extremely low level of multi-threading. Now, if you don't know anything better, that sounds great. But Akka does this. It allows you to define exactly what you need to do. So you would say, instead of, I'll put it like this. This is in Scala. So Akka allows me to say what to do. And that's it. Well, more practically, you will define, like in here, give word to threads. You will say run. Java, you would say run. Maybe thread run. But this is exactly what you would be doing your work. So Akka bypasses all of that. It just says, what do I need to do? I am an individual worker for you, and an individual worker for you is called actor. So I'm an actor. I am ready to accept your commands, and I will talk to other actors. Now, one thread is not enough, of course. We have multiple threads. How do they talk to each other? You need to create a complete mechanism of threads talking to each other. And for example, let's say there's a queue. So that's all. Once I show you what Akka does, that's all very low level. Now with actor, I can say that's what you need to do. That's equivalent to run. So I'm not very precise. That's not what you say in the language, but as a general idea, that's what you do. And so the next question, how do they talk to each other? They send messages. That's how they talk to each other. When they need to communicate, they send messages. So that all is present in Java. And in fact, it is implemented with Java. It's implemented with queues. And the queues is put in front of the actor. The queue is put at the end of the actor. So those messages become the communication mechanism. But look at how abstract that is. All you do is you define what you need to do. And when they need to work together, we'll send each other messages. Somewhere down below, yes, it is implemented with threads. More than that, if you write something like that, if you write this Java, then, well, it works for one computer, right? What if you have another computer? What then? Well, there is no natural translation of all your thread pools to another computer. Well, this here, did it ever ask me, am I on one machine or on a cluster? No, I can have some of my actors in one computer. Let's say it has 128 CPUs. So I have that many CPUs to work on my actors, and actors are usually in the thousands or millions. So I have that, but let's say I have another computer. Well, the framework is transparent. It doesn't even know that I have another computer, so it works on the cluster. That's pretty much what Akka does for you. See, it brings up a new level of abstraction. Now you can appreciate that is kind of what Twitter did, except that there was no Akka back then. Back to the slides. So that's where we are. I think that's a good overview. Let's see if they have some interesting examples. So we already talked about Spark being and domain-specific language for big data. Now, if you want to talk on the service level, well, maybe Spark is pushing Scala into prominence, or was pushing, but that's only the psychological thing. The technical side of it is that it's a new extension of Scala. So let me show you something that happened just a couple hours ago, right? There is another interesting extension of Scala, another DSL of Scala. And that is for creating hardware. Now, you probably know that there is such a thing as TensorFlow Processing Unit, the TPU, the new excellent processor for machine learning, right? And that is what Google does. There is also a TPU in Amazon world. Now that TPU in Amazon world is spelled the same way, but it means a different thing. It means the tranium. So let's put it here. There's enough room here because we're really doing whiteboarding. So TPU stands for TensorFlow. TensorFlow processing unit, but it also stands for Amazon Tranium. Okay, that's a new chip. So all such things have to be programmed somehow, and they're pretty complicated to program. There's a different approaches to hardware, but by now the programmers become closer to the hardware. They can't just ignore that because they're going into multiple threads, multiple processing. So there is yet one more way of doing your hardware. And these two approaches are special chips. But there is a way to reprogram your chip. That's called programmable arrays, right? Programmable arrays, there is an abbreviation for that. Arrays. I'm trying to remember what's that is programmable array, but there is a better way. Well, no, I cannot find it, but that doesn't really matter. What's important is that that's the Microsoft approach. You might remember it right away. Programmable gateways. So these are the three things. And as you can imagine, that's pretty hard. I see somebody is typing FPGA. Perfect. Thank you very much, Randy. So it's a better way to say it. Field programmable gateways. Field programmable gateways. Okay, thanks so much. So it turns out that there is a new language that will allow you to create those hardware chips. So putting back into the software, the programming language is called Chisel. It's an invention again from the same Berkeley. Now Spark came out of Berkeley, so there is this new thing called Chisel. Now there are many chisels in the world. This is one, the Scala. Here you are. It is a language that is based, it's nice, but what we need here is it's a language for hardware construction. There are two approaches for hardware construction. One is more straightforward. It's mentioned here down below. Okay, but this one is a new language out of Berkeley. So that was created, the whole idea was created about the same time that the Spark was created, 2012. But it's alive and well. You can check how it is doing. And there is a community, they have regular conferences, there are releases. So that's yet another DSL. It would be DSL for hardware construction. Again, it's not for everybody, right? It's not your Python, but that's the kind of power that it gives. Now, practically what you would do is you would install IntelliJ, and these are the commands. There are quite a few ways, but to me, they're constantly improving the experience. They're trying to make it simple. So I found this. If you're in the Linux, those 5 lines will give you the whole story for sure and nothing to do, nothing else to do. That's, by the way, one additional nice thing about Scala. Scala will jump from version to version just for you and on your project. So SBT is the simple build tool where you're saying, here's my code, but also please use this version of Scala. And it will say, well, that's not what you have installed on your computer, but that doesn't matter at all because I will download and install the right one just for you. So that's another improvement that they're trying to make. And again, I know I'm repeating this, but that's the last time. Now, don't look for how popular it is. According to the Lightband, that's the company, they are very popular. I spoke to them and I said, what I'm thinking is that you're going to explode this. I said, yes, Mark, yes, we're going to explode. But that doesn't really matter. We are only interested in what we can do. So that's what we can do. Watch for the extra special power that Scala gives you. And other things in Scala that I don't have to advertise are, it's interactive. Java is not, now Scala is. And from then on, those slides, they're just going to why practically you do it, how exactly you do it. And the last thing that I'll mention here is this. You can say val, you can say var. Val means you, the compiler, please understand things. And if that's what I write, then you will understand that x should be integer. When I do this, it will reply, I have created this integer. Now, var is bad. Even though it's here as the first one, really you should always be using val. Val says don't ever change it. Okay, why is that important? Well, because you don't ever have any conflicts. That's a better way to write. This is what kills your getters and setters in Java beans, is because that's even not the right approach. So Scala allows you to do the wrong thing with that, but it really prefers you to be using unchanged and invariable values, immutable, I call, and stay there. So that's one of those things why it is very convenient. Other things I already spoke about. Okay, stopping that show. Oh, at the end here, if you're into it, you will find a few other interesting and good things. For example, Scala has complete lists, and they teach you really how you should behave with collections and lists. Teaches you that you should do what's called the higher order functions. Don't operate on your collections by setting I to 1 and changing that element, setting I to 2, changing that element, but instead call one function that will run on all of the elements in the collections. It's a pretty easy thing, and it gives you a few things. So let's see at the very end, talking about Akka and why it is good, but also at the very end. So ignore the monads. Monads are something that has to do with mathematics, but I think that that picture really tells you. And what it says is that if you're making berry pie, right, then it doesn't really matter what berry, almost doesn't matter. That's what monads are. Once you discover that all of your objects are berries, then you can use different kinds. You know, there is a statement that once you finally understand those monads, then you cannot explain it to anybody. I think that's just because most people don't understand mathematics. Take integer numbers. So they are complete, right? You add two numbers, you get integer number. So, well, that's pretty much what monads are. Enough about monads. And at the end, you will also see the best practices, which again, if you read them, that will give you a good idea that Scala is not just improved Java where you don't have to do open close brackets because it's evident anyway, and you can drop this, but it gives you a much better way to write your code. Move all of the checking, give it over to the compiler. You just write what has to be done. The compiler will do that for you. Okay, cool. Let me stop even the screen share so that what we can do is now, if there are any questions, we can talk about the questions. Okay, sometimes there are no questions, that's fine. So if I ask you just that one question here on the chat, here. Did you see anything new here? In other words, what I was showing is not just how you run Scala, but I was trying to show you how you should look at Scala. What can it give you? So if you saw anything that's new, and who am I talking to? I should be talking to everybody. Let's see. What I said was to just one person. Now I'll restate that same question here. Okay, if anybody saw anything new, then please say yes. Something like that, or raise your hand, something like that. All right, thank you, John. That's great. Cool, so if so, then you will get an automatic link to all of the materials. You'll get a recording of this webinar that you can send to your friends. And today's Friday, so I'm wishing you a very good weekend. Cool. So thank you very much, everybody. I'll wait for a minute or two. Thank you, guys. Thank you, Randy. Thank you, Joshua. Thank you, CEO. Thank you, John. All right. Okay, cool. I have some question. Let's see. Okay, that's questions and answers, which says thanks. So Atano, thank you to you. All right, goodbye until next time.